All right, so we are continuing on with radicals today. So we are looking at what happens when you do not have perfect roots underneath the radical or perfect radicand values. So in order for a radical to be completely reduced, there must be no factors. Get my pen here. So no factors that are nth powers of an integer or polynomial. So what that means is that you should have basically that means that you should have no exponents and or factors of these values that are larger than your index value. So remember, index from yesterday was that number that goes in the radical. So we're looking at our square roots. Now, we've done this a little bit already when back in semester one with values of our numbers here. So the best way that I think to do this is I try to break this down into what's a exponent that is divisible by the index, or what's the next exponent divisible by that index. So when I'm looking at this, now we did this yesterday, so we have an even number, 8, so that even number being that I have an index of 2 is able to be simplified. So we have, that would just be x to the 4th. All right, well, 8, the second example, 8 is not a perfect square, and 11 is not evenly divisible by 2. So we can, again, break down that 8 into 2 times 4 and 2 times 2. So if we write that in terms of an exponent form, that would be 2. Now I'm going to want to use exponents that are divisible by 2. So I have 2 to the third, but that would still be the same as 2 squared times 2. That's still 2 to the third power. So I have 2 and 1. So that is a third power. So that gives me a value that is divisible by 2. We're going to do the same thing with this 11. The value, or x to the 11th, can be rewritten as something that is divisible by 2. So the next number that is smaller than 11 that's divisible by 2 is a 10, right? X to the 10th times x. And that way we are going to be able to take the square root of x to the 10th. So anything divisible by 2, so divisible by 2, this 2 is divisible by 2, this 10 is divisible by 2. So we're going to be able to simplify those values. So the square root of 2 squared is 2. This will stay in the radical. The square root of x to the 10th is x to the 5th, and this x will also stay in. So I'm going to have 2x to the 5th, square root of 2x. All right, let's try it again. So this time I'm just going to have 3 values. Now 12 again is not divisible by, is not a perfect squared number. So that's 2 times 6, which is 2 times 3. So that's going to give me 12. So if I'm going to rewrite this, I would rewrite that as 2 to the 2nd times 3. Now, here again, 21 is not divisible by 2. So I want to break that down to an x to the 20th, because that is divisible by 2, and an x. That's still 21. X to the 20th and x is still x to the 21st. Now, x to the 10th, y to the 10th, 10 is divisible by 2. So I can leave that one alone. All right, so I'm going to leave that as y to the 10th power. So the things that are going to be able to take the square root of are these 3 right here. So 2 to the 2nd, x to the 20th, y to the 10th. So I end up with an answer that is going to be 2, x to the 10th, y to the 5th, and this 3 and this x will stay inside the radical. So I end up with 2x to the 10th, y to the 5th, square root of 3x. All right. Hopefully we're all good there. So moving on to cube roots. Okay, we do the same thing, but what has to happen now? And if you're thinking in your head, oh, I need exponents that are divisible by 3. You are correct. You're exactly right. All right, so let's take a look at this 32 here. So again, if we break down that 32, that's 2 times 16. 2 times 8, 2 times 4, and 2 times 2. So how many 2's do I have there? I have 5. 2 to the 5th. I'm going to want to break that apart so that way I can get something that's divisible by 3 in terms of the exponents. So even though this is 2 to the 5th power, I'm going to want to use 2 to the 3rd times 2 squared. How many exponents is that? 5. Okay, so that's still 2 to the 5th. It's just broken apart in a little way that we can simplify it. All right, whoops. So I have the cube root of that. So the cube root of 2 cubed, 2. But guess what? This guy stays in because the 2 is smaller than the 3. All right, now what is 2 squared? Come on, come on. What's 2 squared? 4. So we can go ahead and just write that as 2 cube root of 4. My handwriting is terrible. I know. I'm sorry. All right. So 16. Is that divisible by 3? Hopefully you said no. All right. What number is divisible by 3? That is smaller than 16. 15. Right. Okay. So we can break that apart. Cube root of x to the 15th x. All right, now I'm going to be able to divide that 15 by that 3. So I end up with x to the 5th cube root, and that guy stays in. So x to the 5th cube root of x. Okay, so I have the cube root of 98, x to the 15th, y to the 28th. So we're going to break down that 98. So that's a 2 times 49, which is 7 times 7. I don't have an exponent, or if I rewrote that, that gives me the cube root of 2 times 7 squared, because I can't do anything else with that. Okay, the x to the 15th is fine. Why is it fine? Because 15 is divisible by 3. But is 28 divisible by 3? No. What number is divisible by 3? Yeah, you in the back. All right, yeah, good job, 27. So you have y to the 27th, y. All right, so we're looking at our exponents. The only thing divisible by 3 is this 15 and 27. All right, you know what? So breaking down 98 did nothing for us because I can't simplify the cube root of that anyway. So we can go ahead and leave it as 98 now. Actually, let me rewrite this. Get rid of that. So I'm going to rewrite that. All right, so what will come out, though, is the x to the 15th and the y to the 27. So 15 divided by 3 is 5. 27 divided by 3 is 9. And like I said before, 98 is not a perfect cube number, so I can just go ahead and leave that as 98. Oop, gotta miss my pen there. All right, so 98, that y is no better, or that 8's no better than what I just had. And then this y will stay inside. So my answer, x to the 5th, y to the 9th, cube root 98y. Okay. Okay, so what we're going to finish off with is just doing some higher powered index values with just variables. So same rule is going to apply. We have a 4th root, so what has to happen? These exponents need to be divisible by 4. All right, the 16, we're good to go. That's all set. But what's not all set is this 5 and this 6. You want numbers that are lower than 4, lower than the 5 and lower than the 6 that are divisible by 4. All right, so I'm just going to rewrite that. So again, I'm going to leave that x to the 16th for a moment. So I have x to the 16th. But how do I need to break apart y to the 5th? I need to break apart into y to the 4th y and z to the 4th z squared. So what's divisible by 4? The 16, the 4, and the z to the 4th. So those will be able to take the root of those. So I'm going to have x to the 4th y z, and what stayed in? This y and this z squared. So when I rewrite that, that gives me the 4th root of y z squared. All right, last couple here. So my index is 5. So I need numbers that are divisible by 5. The 10's good to go. Nope. 27, nope. 30 is good to go. 16, not so much. So we're going to rewrite those so that I get a number that is divisible by 5. So I have, again, I'm just going to leave my x to the 10th, my z for a moment. So I have the 5th root of x to the 10th, but we need to make y to the 27th, y to the 25th, y squared, z to the 30th is good, m to the 15th, m. Why again? Because that's the number that's less than 16, divisible by 5. So what can come out? X to the 10th, y to the 25th, z to the 30th, m to the 15th. What's going to stay in? This guy and this guy. So our final answer, x squared, y to the 5th, z to the 6th, 5th root, y to the 25th, or no, I'm sorry, not y to the 25th, y squared, get rid of that 5 there. There we go. Y squared and m. So x to the 2nd, y to the 5th, z to the 6th, 5th root, y squared of m. All right, last one. Last one's a little bit shorter. That was supposed to be a practice one if we were actually in class. But I need numbers that are divisible by 4. What's divisible by 4? The 28. What's not? The 17. So what do we need to make that 17 become? A 16. Yes, and an x. So y to the 28th was fine because that's divisible. So what's divisible by 4? These two values. So we're going to divide those. So I have x to the 4th, y to the 7th, and remember this guy stays in because it's got an exponent smaller than 4, our index. So the 4th root of x. Okay, there we go. And that is today's lesson. Okay, again, email me if you have any questions at all. Have a good day, guys.